This is Notes 13-4, Converting Quadratic Functions with the Calculator. So today we're going to look at functions that are both in vertex form and in standard form. And we are going to use our calculator to compare to see which ones are the same. So number 1 says which function is equivalent to f of x equals negative 4 x plus 7 squared minus 6. In my calculator, I'm going to type in that equation, negative 4 x plus 7 squared minus 6, and take a look at the graph. I'm going to go through and graph A, B, C, and D to see which one matches up exactly with my question problem. Okay, I should only see one graph if it matches up exactly. So choice A says negative 4 x squared minus 56x minus 202. Okay, I don't see another graph. I'm going to zoom out a little bit just to make sure. Alright, I only see one graph, so far this one looks good. To compare, I can also look at the table. Second graph. If I look at the table, all my y values match. My table is exactly the same for both functions, so my correct answer has to be A. To show you what it would look like if it was wrong, if I graphed choice B, negative 4x squared plus 14x plus 43, I could see here that I have two different graphs, so these could not match, and that's what each C and D would look like. Okay, number 2, which of the following graphs is a parabola with a vertex at negative 10, 0 that goes through the point 1, 60.5? Alright, back to y equals. I'm going to clear out what I have, and I'm going to graph each one of these and look at the graph to see the vertex and look at the table to see this point. Now, I do know something about vertex form. Looking at these, I know that vertex form is y equals a x minus h squared plus k. So for this problem, h is my x value, negative 10, x minus negative 10, two negatives make a positive, plus 0. So I should not see plus anything on the end. That rules out option C and option D. Okay, to decide between A and B, I'm going to graph each of these, look at my table to see which one has the point 1, 60.5. Starting with choice A, 2 x plus 10 squared. Checking out my table. Whoopsies. At the point 1, I have 242. So it can't be A. I'm going to double check B just to make sure I didn't make a mistake. Instead of 2, I have 1 over 2, 1/2. Another way, instead of using my table, I could just type in an x value. So trace, the x value that I have for my question is 1. And it gives me that the y value is 60.5. Exactly what we want. The correct answer is B. If you prefer to use the table, second graph, I have 1 and 60.5. Number 3, which function is represented by the graph? Okay, I need to make sure that one of these matches the graph that I have. So I'm going to label a few points. I can see here, barely, that my vertex is the point negative 1, 10. And I can see that my y-intercept is the point 0, 9. Remember, the y-intercept should be our c value in standard form. My x-intercepts don't look like exact points. It looks like they're between negative 4 and negative 5 and between 2 and 3. So, knowing my y value, has to be 9. That has to be my c value. If I look at the c values of each of these equations in standard form, the correct answer has to be B. That's the only one with a y-intercept of 9. To double check it in my graph, I can type this in, negative x squared. Oops. Let me try again. Negative x squared minus 2x plus 9. If I do zoom 6 to get this back to a normal graph, I can see my y-intercept is up here at 9. My x-intercept on the left is about negative 4, and on the right it's about positive 2, just like the graph on my paper. Another thing to notice, this graph is going down, so my a value has to be negative. Automatically that would rule off c and d because x squared is positive. Last one, looking at number 4. Which function is best represented by this graph? Okay. Notice here that all my a values are positive, so all of these have a graph opening up. They are in vertex form. I notice they all also have the numbers 3 and 5, so I'm going to look for a point with 3, 5 on my graph. I know it's not positive 3 and positive 5 because there's no point there. So let's try negative 3, negative 5 is my vertex. Vertex form is a times x minus h squared plus k. H and k from our vertex. So a times x minus negative 3 has to be the opposite. Two negatives make a positive. I'd need an equation that has plus 3. That rules off c and a, plus k. So plus a negative 5 is just minus 5. This could be option B or option D. Okay, to graph these, I'm going to type in the first one, 2 parentheses x plus 3 squared minus 5. Okay, this looks kind of similar to the graph I have on my paper, except that notice here, this x-intercept is positive. On my calculator, that x-intercept is negative, so it can't be option B. Let's check option D. I'm going to change this 2 to a 1 over 2, 1/2. And this graph looks much better. I have an x-intercept between negative 6 and negative 7. And I have one that's just on the positive side of 0. So our correct answer is option D. This is the end of Notes 13-4.